Bismillah. Today we are going to discuss a very important problem in resultant of the magnetic fields, uh, which is May 15. Two straight wires A and B are placed 1 meter apart from each other. The intensity of current flowing through A 4.5 ampere, and that flowing through B is 1.5 ampere in the same direction. A circular coil of one turn and radius equal 10 by centimeter. Radius 10 by centimeter is placed between the two wires in the same plane, and its center is at a distance 0.5 meter from the wire A. That is, it is away from 0.5 meter from the wire B. When subtraction, we can conclude that this distance is also 0.5 meter long. As shown in the figure. What are the intensity and direction of the current passing through the coil such that it will be total at the center equals 0? Here we have three fields get in at one point to make a resultant equal 0, and our mission here is to conclude in what direction the coil field will be, whether the coil add its value to the wire, the field of A, or the field of B. Analyzing the problem, we have here left side and right side, and if we compare the field of A, we notice that its value has 4.5 ampere, while the wire B, its value has 1.5 ampere. Also, they are opposite in direction. Keep concentration, please. The wire B is represented by this pin, and this is the current of B, and its field inward. LB, its field inward. On the other hand, LA, this is A direction. I keep the A direction and I rotate my fingers to be outward at the center. يبقى الواير A makes outward field. Returning to our answer, we can conclude that the field of A is more than the field of B, and as a result, the circle will add its value to the less value of B to make an equilibrium, or to make equality between the two sides, which is طبعا a neutral point. يبقى why B add its value to inward? Because outward is more than inward. Keep in mind and that I have concluded that when comparing the current of A and B. So we have now an equation. We must solve it. Solving the problem to get the value of the field, we find that it is output from the subtraction 1.2 times 10 power negative 6 Tesla, and I'm going to keep I at a side. After some calculation, I equal B to R divided by mu n, and here el pi is simplified with el pi, so it's a pi, and we have here conversion in meter. So the current as a value is 0.6 ampere, and here we have to study the coil itself to know what is the direction of the current, and okay, are you concentrating here الفيلد inward الفيلد of الكويل inward to make neutral point and the current. If we use the screw we have a screw in a condition of fastening. بنربط السكرو clockwise so the current moves in clockwise direction so as to make the field inward. يبقى الكرنت clockwise so as to make the field inward. And that's all for now. Hopefully you like the video and gain the benefit of its study. Thank you.